Good day, guys. All right, so in this video, I want to cover the 3 Newton's laws of motion, and then I would like to discuss two simple examples of how to calculate net forces. All right. Okay, so let's get into it. The first of the Newton's laws of motion states that an isolated body moves with constant velocity, right? Unless an external force acts upon it. So once an external force acts upon it, then it's not isolated anymore, right? So it is by definition, if it's isolated, it will always move at constant velocity. Mathematically, we say that, okay, if there's no force, then the velocity of the body will always be constant, okay? So the next law, the second law, should be familiar to you. It's F equals to ma. I mean, at least that's what you've learned in your secondary school. In the matriculation level, you are required to know that F is actually equals to the rate of change. So when you see rate of change, it means over dt, right? Of linear momentum of a body, right? So F equals to dp over dt. Okay, so how do you get F equals to ma from this equation then? Well, we can use our definition for momentum, right? To get d over dt equals to, bracket mv. So because we know P equals to mv, right? Okay, so at this point, we can assume that mass is going to be constant. Therefore, you have m dv over dt. So here to here, what you have is mass equals to constant. Okay, and then you use the definition of A equals to dv over dt to get F equals to ma. All right. Okay, so that's how you get F equals to ma from dp over dt. Now, of course, this case changes if the mass is not constant. For example, in rockets, as the rocket flies up, it will burn more fuel, and those fuel will be ejected out. Therefore, the mass will differ as it flies out. All right. Okay, so the third law will says that whenever two bodies interact, so let's say body 1 and body 2, right? So body 1 and body 2, 1 and 2, the force F21, which one exerts on 2, so that's F21, is equal in magnitude and opposite to the force F21. Sorry, 1, 2. So what that means is that F21 is going to be minus F12. All right. Okay. So let's do simple examples as how we can calculate net forces. So in this first case, we have a one-dimensional case. And what we can determine is that, okay, this is the positive y direction. So I know that my F net is going to be my Fy. And that Fy is going to be, so 3 is in the positive y direction, us, and 5 is in the negative y direction. So what I have is negative 2n downwards, right? Okay, so that's fairly simple, right? You just add those forces together. Now, what do you do then if they are two-dimensional? So here we have a two-dimensional case. Still example 1, but we have a two-dimensional case. So as we've calculated, 5 and 3, right, is just 2 Newton downwards. So we can convert this picture into this picture. So I have 2 Newton, and then I have 4 Newton here. And the F net is going to be a resolution or a combination of these two forces. So it's going to be, let's just change colors to green. Okay, so this is going to be your F net. F net. Okay, so you can say that, okay, 4 is the F net in x direction, and 2 is the F net in the y direction. So here you can use Pythagoras theorem. Let me just change colors again. I can use Pythagoras theorem. Pythagoras theorem to say that my f net is going to be the square root of negative 2n squared plus 4n squared, right? Square rooted. And that is going to be give me approximately 4.47 Newton. However, for the case of two dimensions, you have to mention the angles as well, right? So you have to know or calculate the angles. So let me just redraw this particular diagram, the next slide. But let me just change something. So I have the same 4 Newton here again. I have here the 2 Newton. So I've shifted from left to right. Then I have F net over here. And I have theta here. So that's the angle with the x-axis. So to find the angle, we can use trigonometry. So we can use trig, which tells me that tangent theta is going to give me 2 over 4, right? So 2 over 4 or negative 2 over 4, and my angle will be approximately negative 26 degrees. Let me just reconfirm that. So that's going to be 26.5.6. So it's going to be approximately 26.6 degrees. So for two-dimensional case, it is important for you to tell me what is the angle as well as the magnitude. Okay, so it's most useful to draw this out. Okay, so that is the end. So I've given you two very simple examples, one in one-dimensional and the second one in two-dimensional. All right, and I've shown you how you can use, for the two-dimensional case, you can use Pythagoras' theorem and the trigonometry identity. All right, so that is all for this video. In the next video, I'll be discussing chapter 5, right? Chapter 5, where we start talking about work, energy, and power. All right, so that is all from me in this video. Thank you very much.